Hi, I'm Chaturya, and I warmly welcome you to our project analyzing ancient Greek verse descriptions with artificial intelligence and natural language processing as part of the Trendall AI Center. So, in this presentation, me along with Nick, Swarna, Benjamin, Jimmy, we will go ahead giving you insights on what we've done so far, to introductions to overviews, scope, stakeholders, different NLP tools, different AI tools, and the minimum viable product that we have been able to create so far. So without much ado, let's move on to the next slide where I will give you Trendall AI Center, which basically is a unit or a research center that was developed in 2018 and launched, led by Latrobe University and worked upon by a group of computer science students as well as researchers, where its main vision and goal lies in converting PDFs, photographs of ancient Greek verses, and making sure that there's a digital archive created by the end of all this, so that researchers such as Trendall, who has contributed to this field in the past, their work doesn't get forgotten. It's all digitized so that a wide audience can basically review, do much research upon, work upon. So that's the main goal and the vision. And in terms of the archive, it will basically include the images of the verses along with the descriptions. And by descriptions, I mean we are going to break it down to intricate details so that every entity is basically covered, and it's a much strengthened or strong database to work on. So that's basically what AI Trendall AI Center stands for. And basically, this enables cutting edge research. And let's move on to the next slide. Yes, and as previously mentioned, we do not plan to stop there. We have future works as well. We want to expand this research. We want to make it available to the wider public via a website, and we want to use the latest tools as well. So this is the industry that will keep on improving, and we will be using the latest cutting edge tools, AI, LLMs, multimodals in order to annotate and absorb as or acquire as many intricate details as possible and digitize, automate it as much as we can and make it available to the wider audience. In terms of the scope of the project, this was well defined at the start of our project with the help of our stakeholders, which you'll see shortly. So the main objective in terms of this project scope that we need to deliver by December is to apply natural language processing as well as multimodal artificial intelligence to analyze these Greek vase images, where we were provided with a few scanned images, and the main task is to uncover or unearth these patterns and shifts over the time, which is basically going to be a huge contribution to the field of archaeology. And as the end goal, we do have plans to do this research report with all the details that we've discovered so far documented properly. And this could also extend to more like a research paper that could be published over time. So visualizations of these changes with regards to data analysis, documents, methods, tools, all this will be documented. My colleagues will also cover this in more detail in the later parts of the presentation, but that is the core deliverable. And in terms of the key requirements, we have discussions on the various tools that we can utilize. For example, NLP tools would mean Python to topic modeling, POS tagging, all this could be used to develop that database, the core database that we're talking about. And then the success criteria will be delivering it on time, making sure by December or early November that we do have this final product and this research report that can be worked upon and developed so that the end goal of Trendall AI Center or the vision is satisfied. In terms of the key stakeholders, one of the first things that we did before the start of the project was putting this table together so that we know who our key players are and what their interests and what their role is going to be, as well as we know from the product owner point of view who to contact. So Nick will be our leader. he will be basically leading, but we as a team, Jimmy, Shivapriya, me, Swarna, Benjamin, will also be contributing and putting our A-level or A game in order to contribute and have that viable product at the end of this project. Scott is a lecturer as well as a supervisor, so he will be guiding us, and Dr. Judith and Dr. Jillian will be the product owners, and they've given us massive support in terms of getting through this project so far. So huge credit to them. And Dr. Yang is also one of the lecturers and also one of the IT experts, and she has also been a key contributor, contributing to answering our questions and guiding us as much as possible.
The main source of data is from the Red Vases of Paestum by A.D. Trendall, an archaeologist who's primarily known for his work on analyzing Greek ceramics. The text primarily contains information about the various vases that he has analyzed, mainly containing what each of the vases depicts. These descriptions can then be used for sentiment analysis, for comparison, and to describe patterns found from his descriptive language.
The previous students worked on extracting text data from Trendall's PDF files. They processed the content and converted it into a Word document format for easier access. The output is called master document, which include two primary components, a detailed table of contents and row descriptions for the vases. This transformation provides a foundational dataset, but requires further refinement for deeper analysis, as the descriptions were still in their unstructured form. The left-hand side is a demonstration of original PDF file. The second slide is an example of master document.
The main goal is to use a variety of NLP techniques and tools to find which is best for analysis. These will be explained more in detail later on. The main techniques use the term frequency. These can identify certain keywords Trendall commonly used for analysis for each vase. So for example, if the word woman appears, it may dictate the subject mainly used was a woman. Bigram and trigram analysis can then be used to find the most occurring pairs and phrases Trendall used to give further context to said keywords. So standing drape woman indicates a visual portrayal of women in specific poses or actions. Clustering can then be used to find vases with similar themes.
The key output of our work is going to be a research report. It's going to detail our progress towards the four major questions posed to us by the Trendall team. So they were interested in knowing which software or machine learning or natural language processing techniques were most useful towards a deeper understanding of the vase descriptions, what semantic clustering or semantic tagging techniques generated the most useful annotations or attribute descriptions of the vase descriptions, and also a comparison of or an analysis of any differences or correlations between the descriptions of different painters or workshops and different fabrics or regions.
One of the main challenges we faced was that the master document was unstructured, which made it difficult to analyze. Our approach was to transform the unstructured text into a data frame for better analysis. The master document includes descriptive blocks, which are our main focus. Each block contains three key pieces of information: the title, references, and descriptions. To process this, we use regular expression to extract these elements and output them into three main columns: title, references, and descriptions. For the description column, we conducted several key data cleaning and processing steps. First, we removed the irrelevant or noisy entries, such as description with fewer than 4 words, which are short descriptions. Next, we converted all descriptions to lowercase to ensure consistency across the dataset. We also addressed the text noise, correcting issues like spacing errors. For example, the woman with space in between. I refer to word woman. Additionally, we identified and preserved meaningful terms that include stop words, such as R stop words hand, which refers to right hand. Finally, we removed all general stop words, punctuations, and other noises, and also ensure the important terms were preserved. This slide shows our fully cleaned output.
So the first hurdle we ran into was, how do we keep everything neat and tidy? Across the 6 to 8 different modules we will be running, how do we keep all of our outputs uniform and reusable? So we had 3 options to investigate to keep everything together: either open source packages, a relational database, or a custom class or module. On the open source side of things, we had a look at NLTK and Spacey. Both provide options to create what's called a corpus, so a list of documents turned into an indexed dictionary, essentially. But we found that they were quite limited because that's the only functionality they provided, and the amount of effort going into relying on those open source packages was outweighed by that limited functionality. In terms of a relational database, similarly, we would have had to go through the effort of, even though everything would be nice and neat being in a relational database, we would then have to convert relational database queries like select and join into things usable in the machine learning space to convert those things back into a usable data frame or vector. So instead we went for the third option to write our own module, which we could make specifically fit for purpose for the whole project, not just that first step of creating a corpus. So I've written 2 modules, one a corpus creator, so that's going to do the role that is available through NLTK and Spacey, but with none of the overhead of using someone else's open source code. The second's a corpus reader, so that's going to allow us to pick up saved and indexed files, and then also the ability to save new attributes generated from those index descriptions to the same index. So keeping everything neat and together, creating that data integrity that will be provided by a relational database. So doing it this way, we've been able to achieve some an extensible, maintainable, and scalable solution to this problem.
In Cappy's research, he used computer vision techniques to classify images of vases. He defined 6 levels of entities and their subcategories. In our project, we are adopting Cappy's finding as the foundation of our description classification. We're applying these categories to the textual description in our dataset. We have uploaded a supplemental material regarding his finding. Our approach for applying Cappy's framework involved several key steps. First, we create a lexicon of entities by using bigram and trigram analyze to identify the top 100 most frequent terms in the description. By applying bigram and trigram analyze, we can focus on high-frequency terms rather than the entire descriptions, which improve the efficiency of our analyze. Next, we apply part-of-speech tagging to refine these terms, ensure they are accurately categorized. Finally, we manually map the refined entities into KP's ontological categories, building a structured lexicon. Next step, we'll confirm the lexicon with project owner to ensure the accuracy. Following that, we will conduct further analysis using customized NLP model to discover the deeper semantic relationships in the descriptions. This is a demonstration of bigram and trigram analyze and the part-of-speech tagging. This is an example of our lexicon before review with project owner.
I'll walk you through some of the techniques and insights we are expecting to gather from analyzing descriptions of ancient Greek vases. Our project is focused on uncovering the evolution of language across these descriptions using advanced NLP techniques. Even though the final results aren't available yet, I'll present the methods we are applying, such as DB scan and LDA, to reveal potential patterns in the language used to describe these vases over time. The techniques we are using include DB-scan and LDA. DB-scan is a powerful tool for clustering terms into groups, helping us find common themes in diverse descriptions. LDA, on the other hand, help us uncover the latent themes like mythological figures or decorative techniques that emerge over different periods. While the final results are still pending, these slides show what we expect to see: clear groupings of descriptions that reflect stylistic changes in the language used. Here's a mock-up of what our clustering analysis might look like. We expect DB-scan to identify clusters centered around recurrent themes such as mythological figures or specific decorative techniques. While this visualization represents our expectations, that the actual clusters may reveal additional insights once we finalize the data processing.
One of the key items of interest for the Trendall team is an analysis of the nature of the language used in the descriptions across the Trendall catalogue. So we've chosen to use topic analysis as our tool to investigate those characters. So the two options for that, which work pretty much similarly, the latent Dirichlet allocation and the non-negative matrix approximation. Both will take a vector, which represents each description or document, and then break that down into a list of topics, which have a high probability of containing a list of words or semantic features which we've extracted. So we're going to attempt to essentially answer the question that if we take these textual descriptions and break them down analytically into a feature vector, a rich feature vector containing any number of natural language processing techniques, if we can answer the question empirically, how much are these two descriptions similar? Not these specific two, but any two descriptions. So what about the first description is definitely and categorically different to the second description? And then we can go on to analyze how those characters of language evolve over the 60 years of the Trendall catalogue.
Moving on, we plan to track how frequently certain terms appear in vast descriptions over time. This mock-up line graph illustrates that we expect to see trends in the emphasis of certain subjects, like Heracles or Satyr, across different centuries. By examining term frequency, we hope to highlight shift in focus and thematic evolution over time. Tracking term frequency over time allows us to identify trends in how certain subjects were emphasized across historical periods. This graph shows how often terms like Heracles or Satyr appear over different centuries. By analyzing these shifts, we gain a clearer picture of how different themes gain or lose prominence in vast descriptions, which may reflect broader shifts in artistic or cultural focus. This word cloud is another expected visualization that will display on the most of frequently used terms in the West descriptions. Larger words indicate more frequent use, giving us an immediate sense of dominant themes. In this mock-up, terms like Dionysus and Satyr stand out, which reflects the type of analysis we hope to achieve once we process the full data set. We also plan to use network diagrams to show relationship between key terms. This mock-up diagram illustrates how we expect to see terms like Heracles linked with his labors or Satyr connected with wine-related themes. These diagrams will help us understand how different elements of vast descriptions are related to one another and how themes evolve together. In conclusion, although we are still working on processing the data, these expected visualizations provide a glimpse into what we hope to uncover. The clustering word clouds and network diagrams will help us track the evolution of language, themes, and artistic styles in Trendall's vast description. I look forward to sharing final results with you soon.
Today, I'll be walking you through how we are collaborating on our project and the tools and the strategies we are using to manage it. We will cover everything from how we communicate and organize our work and the platforms we use for version control and documentation. I'll also give you an overview of the project scope and the key deliverables we aim to accomplish by the end. In this project, our management strategies revolve around collaboration, communication, and keeping track of our progress using key tools. We have implemented systems to make sure every team member is on the same page, and we are continuously optimizing our approach to reach our project goals on time. I'll now walk you through the key methods we are using to manage our project and tools that support this. So we use Microsoft Teams for day-to-day communication. We hold two key meetings every week on Saturdays and on Tuesdays. So on Saturdays we review the progress made during the week, discussing what each member has worked on. This gives us a chance to stay updated on the project development and address any blockers. And on Tuesday, we look ahead, assigning tasks and planning the upcoming sprint. This allows us to stay on track with our project timeline. All discussions and key decisions from the meetings are documented on Confluence for reference, ensuring that nothing important is overlooked and everything is available on the Teams at all the time. And next we have GitHub. We use GitHub to collaborate code. To manage our code effectively, we rely on GitHub. Each team member contributes their part of the code to the repository, particularly for the MVP modules. GitHub allows us to use version control so we can easily track changes, review code, and ensure everything is integrated smoothly. This also ensures that any team members can access another member's work and make adjustments without risk of data loss or mismanagement. GitHub serves as a central place where we can collaborate on code in real time. Next up, we have standard development environment. To maintain consistency across the team, we have to standardize our development environment. Most of us are using VS Code for coding, which helps us to avoid compatibility issues. For machine learning tasks that requires more computation power, I personally use Google Colab, where I can run experiments using its GPU resources. Additionally, some team members use Jupyter notebooks for data exploration and quick iterations, which easily integrates into our workflow. This standardization minimizes errors caused by differing setups and ensures everyone can work together without technical hurdles. And next up, we have Confluence as a central hub for documentation. This is where we track our milestone, keep detailed notes on research, and organize our sprints. And also the discussions we made in team meetings, we actually post in Confluence. It allows us to stay aligned as a team, provides visibility into our project progress. Having everything stored in one place means we can quickly refer. We have a reference to a previous work, identify where we are in the timeline, and ensure that all our research and discussions are well documented for the future use. Confluence is a key of maintaining clarity and organization of our project.
For our, for our sprint design, each sprint usually lasts between 1 to 2 weeks depending on the amount of work that needs to be done. During this time, we arrange 2 meetings per week to see what each of us has done, any problems that need to be discussed, and what we're going to do next before our next meeting. After each sprint, we then do a sprint review in which the Scrum Master will present all of our progress for the overall sprint. Within these sprint meetings, as stated previously, we discuss the progress we've done currently, any problems that we may be facing. We discuss the MVP progress to see if we're on track or if we may need more time to complete the tasks. Any tasks that are redundant due to changes are removed from the backlog completely, and we schedule what day our next meeting is. Usually it's one on the weekend and one on the Tuesday. Any information discussed is noted and sent to everyone to ensure everyone knows what everyone else is doing. There are two MVP versions that we have planned. MVP V1 is mainly about getting each part of the code working, with the correct inputs and outputs, no additional errors occurring, like any syntax errors, any spelling errors, or anything that's outside the input and output errors that we usually have. And for each part of the code needs to be documented, mainly what each part of the code does. This will be mainly used for our final report that we have to present. MVP V2 will be mainly about using the techniques found in MVP V1 and comparing them to find this best solution for each of the different tasks. Additionally, we want to keep data integrity and reliability to ensure that everything is correct, pretty much. That there, as again, additionally, there's no errors or anything of that nature. There are five primary milestones for this project that we will need to achieve for completing the project, pretty much. The first milestone is to ensure that all parts of the code is functional, that there are no errors present, and that each part of the code is worked on, is documented for clarification, and is to then be used for the final overall report. The second milestone is to check for key performance metrics slash baseline performance for each module, to set a viability target for each module, to check the level of performance for each module for satisfying the project outcome. Third milestone should document what the current performance is for each module, any main problems that have occurred, and how we can improve it alongside any documentation for the improvement. By then, we should also have a set of options of techniques to be then used for MVP V2. Fourth milestone will have the final design of MVP V2 documented and have the performance tested for each of the software techniques selected from MVP V1. Our fifth milestone will have all the main MVP V1 and V2 documentation done. This will then be used for our final report, in which we'll answer what NLP tools and techniques were the most useful or had the best performance in analyzing Trendall's face descriptions and language patterns. We'll also have our final tuned models and outputs of MVP V1 and V2 in the main GitHub repo, and we'll have all of our code commented to ensure that other people can read it and can replicate it if needed.
And now we have our scope of work. So, our project governance is centered around structured planning and clear milestones. The scope of our work is involved applying NLP and multimodal AI to analyze 60 years of A.D. Trendall's Greek vase descriptions. The primary focus is to uncover linguistic patterns and understand how these descriptions have evolved over time. We aim to maintain strong project governance by clearly defining each team member roles and responsibilities, ensuring timely delivery and mitigate risks as they arise. This structured approach will help us stay aligned with our objectives and efficiently manage any challenges throughout the project. So by the end of this project, we will deliver a functional reusable code base for processing and analyzing vast descriptions using NLP techniques, enabling insights into linguistic shifts. Over time, we will also produce visualization illustrating these changes and a comprehensive research. Um, so the report on the NLP tools, clustering methods, and correlation with vast reclassification, all these findings and documentation will support future research in the field. Thank you.